Okay, good morning. Welcome to
FamilyMath967.
FamilyMath967. So today we're continuing our walk through Mosteller's 50 challenging problems in probability. And today we're going to take a look at problem number 8. Let me get that more in the center of the screen. So it says the perfect bridge hand. So you want to read that?
Okay, so we often read of someone who has been dealt 13 spades at a bridge. With a well-shuffled pack of cards, what is the chance that you are dealt the perfect hand, 13 of one suit? Bridge is played with an ordinary pack of 52 cards, 13 in each of 4 suits, and each of 4 players is dealt 13.
Okay, so you take a normal deck of cards, and shuffle them up really, really good, and you deal out 13 cards to each player. And so the question here is, what is the probability, if you're that player, or one of the players, you're one of those players, what's the probability that you get 13 spades?
Or no, 13 of one suit, I think.
Oh, sorry. Yeah, 13 of one suit. It's the probability that you get 13 of one suit. So let's zoom out. And let's talk about how we would approach this problem. So let's not solve it right now, but let's just talk about what we might do.
Alright. We can just solve it for one suit, I guess spades, since they keep using spades. We can solve for one suit, then multiply our number by 4.
Right, write something down.
So, let's just solve for one suit, and then times 4 at the end.
Okay, that's a good simplifying observation. Why does that work? Can you tell me?
Well, if you solve for one suit, and then, so each of the probabilities for getting 13 of that suit is the same. So you just have to multiply the probability by 4.
Okay, great. What are some other things we're going to have to think about solving this problem?
We need to think about the fact that we have 4 players, I guess. So,
Well, I guess, yeah.
we don't need every player to have the 13 of one suit. So, we just need to keep track that there are other players that might impact our probabilities.
Okay.
And maybe the method of dealing.
Oh, that's
I
an
guess.
interesting one. Let's talk about that. Do you think the method of dealing? So let's assume. Let's put aside the shuffling for a second. Let's just assume we all agree that it's perfectly well shuffled.
Okay.
Okay. Do you think the method of dealing the cards impacts?
Well,
Probability.
there are like two
Ways.
two ways to deal. You can, so you're gonna start here. You can go around the circle like this and keep dealing cards like that.
Uh-huh.
Or you can deal with 13 to this person, and then to this person, and then to this person, and then to this person. I think the first way is how you're supposed to deal.
Yeah. But also they could be different. So if you're trying to get 13 of one suit, so you'd have like 13, so you'd have 13 out of 52 getting first card, but then the second card would change because if you need to get the second spade in the first method, you need to go 12 out of 51, 12 out of 50. It would be 12 out of 48.
Uh-huh.
But in the second method, they would all have to be in a row, so it'd just be 12 out of 51.
So I don't know which would have a lower probability or not, or if it matters even.
Okay.
We
yeah.
could. I think you're supposed to do it where you start it with one person,
And
you
then
deal
go
around in a
around,
circle.
yeah.
All right.
So maybe we calculate it with that way, and then we use that as our way.
Okay. Well, maybe we should actually do both ways to see, because we're not sure if it matters or not.
Okay.
Yeah, it's certainly interesting to think about how it might work out. All right, let's take a look.